In this video, I will be going over your Exam 3 review. First question says that Jamie swims 1/3 the length of the swimming pool every 1/6 of a minute. Enter the number of swimming pool lengths Jamie swims per minute. So first part of the problem here is writing my ratio. So I know he swims 1/3 the length of the swimming pool. So I'm going to put length of swimming pool every 1/6 of a minute. I want to know how far he will go every 1 minute. So I'm going to divide top and bottom by 1/6. So that means I'm doing 1/3 divided by 1/6. And this is where you want to type that into your calculator. So let me pull it over here. Here's our calculator. Remember to use this one, desmos.com/scientific. And we have 1/3 divided by 1/6. And when I do that, I figure out my final answer here should be 2. So that means that Jamie can swim 2 swimming pool lengths every 1 minute. Next question says that a recipe asks for 3 ingredients to be mixed together as follows. Add 1/2 of a cup of flour for every 1/2 of a teaspoon of baking soda and every 1/2 of a teaspoon of salt. Which rate is a unit rate equivalent to the ratios shown? Okay, so there's a lot going on in this question, and the main part here is you want to make sure you're keeping your units the same on top and you're keeping your units the same on bottom. Okay, and another thing we want to look for here is we want to have our 1 second because we want to have a unit rate. And in order for us to have a unit rate, we need a 1 in the denominator, which means our 1 needs to come second in our description. So here where it says for every 2 teaspoons, this is not correct. So it can't be that one, which means we're left with these 3 here. And what we want to do, so this first one here is talking about 2 teaspoons of salt for every 1 teaspoon of baking soda. So I'm going to look up at my problem and see where it's talking about salt and where it's talking about baking soda. Okay, salt comes first, so I'm going to put 1/4 of a teaspoon of salt over 1/2 of a teaspoon of baking soda. So one thing I want to tell you here is I want to know for every 1. So that means I'm going to divide top and bottom by 1/2. Which means to get my answer, I'm going to be doing 1/4 divided by 1/2. And if I type that into my calculator, I get 0.5. 0.5 is another way of saying 1/2. 1/2 is not 2, right? That is not the same. So that means this is wrong. However, if I look down here at option D, I have 1/2 a teaspoon of salt per 1 teaspoon of baking soda. So based off this up here, this is telling me 1/2 of a teaspoon of salt for every 1 teaspoon of baking soda. And that is what this ratio down here is telling me. So the correct unit rate for this expression is 1/2 a teaspoon of salt per 1 teaspoon of baking soda. Our next question says that Jitters sells a 12-ounce cup of coffee for $1.80, and she sells a 20-ounce cup for $3. What we want to do for this problem here is we want to find the unit rate of each of these cups of coffee. So if she pays $1.80 for a 12-ounce cup, so let's write that ratio. And then she's paying $3 for a 20-ounce cup. So what this is going to tell us is it's going to tell us if they're cheaper, if one is more than the other, and so on. So let's type this into our calculator. 1.8 divided by 12 and 3 divided by 20. So on both of these, I get 0.15, which tells me that I am paying 15 cents for each ounce of coffee, and I'm paying the same amount for each cup. So that means that both cup sizes are going to cost the same per ounce. So not one is a better deal than the other. Both are a good deal because you're paying the same amount for each ounce. Our next question says, does the graph show a proportional relationship between the pounds of apples and the price? Remember that in order for a graph to be proportional, it must be straight and it must go through the origin. If I look at the line here is straight. However, it does not pass through the origin, which is right here. So no, the graph is not proportional because it doesn't go through the origin. And remember, the origin is 0, 0 on your graph, which is down here. Our next question says the the graph below shows the number of calories burned when someone rides a bike. At what rate are calories burned by bike riding? Okay, so we want to figure out how many calories you burn each minute you are riding your bike. On this graph, we don't have any dots, right? It doesn't tell us any points that are good necessarily to use, so it's up to us to look on the graph and see which point is best. Remember that you want to pick a point where your line of your graph intersects directly in the middle of your grid lines. Okay, so if I'm going to follow my graph along here, this right here is the first point that I see of my line, and it passes right through the center of those grid lines. So I'm going to follow this point straight down and straight to the left. This is going to be 10 and 40. So this point is 10. Whoops. This point is 10, 40. Remember, this is my xy, 10, 40. I want to write it as y over x, which means I would have 40 over 10. Don't forget to reduce it to 1, dividing top and bottom by 10. So 40 divided by 10 is 4, which means I'm going to burn 4 calories per minute bike riding. Our next question says 6 customers are buying gasoline at Miguel's gasoline station. The number of gallons bought and the total cost of their purchase are plotted on the graph below. What is the price per gallon of Miguel's gas station? So I want to know how much I'm paying for every 1 gallon of gas. I can use any of these points here. Let's use this one right here. If I follow it straight down, my x is 4, and straight across my y is going to be 10. Remember, I want to write it as y over x, which means I'm going to have 10 over 4. I want to know this bottom number represents gallons. I want to know how much I'm paying per gallon. Remember, per is another way of saying 1. Let us divide top and bottom by 4. So 10 divided by 4. For this one, especially since it's an exam, I would recommend double checking it in your calculator. 10 divided by 4 is 250, which means I am paying $2.50 for each gallon of gas at this station. Next table says, which table shows a proportional relationship between the time spent reading and the number of pages read? For this problem, what you want to do is you need to type into your calculator all of your y over x ratios and see which table gives you the exact same simplified number. When you're looking at a table, your x is going to come first, okay, and your y is going to come second. So let's look at our first table here. X comes first, y comes second. Remember, I'm putting it in y over x. So my first ratio here is going to be 5 over 10, 10 over 20, 15 over 30. And we can type that into a calculator and see when we simplify it, do we get the same number or are they different? So 5 over 10, 10 over 20, 15 over 30. Here, when I type all three of these in, they all reduce to the same exact number. So that means that this table here is proportional because they all reduce to the same. Let's check this one on the bottom underneath it, just so that you can see what happens when it's not proportional. So I would have 2 over 10. I would have 30 over 15. And then I would have 25 over 20. So you can see here that all three of these are different numbers, and since they're all different numbers, that means this table here is not proportional. So you're looking for all three ratios to reduce to the same number. Our next question, we want to select the two tables that represent a proportional relationship. On this one here, guys, you have to be extremely careful, okay, because these numbers kind of look like they're already in a ratio, right? If I look here, this kind of looks like a 1/2, but remember, it's labeled X and then it's labeled Y. We need to write all of our ratios as Y over X, which means all of these need to be flipped, okay? So if I'm looking here at this first pair, I would have -4 on top over -2. The second pair here, my Y is -2 over -1. I have a 0 over 0. And then this last one, I would have 2 over 1. Okay, so be very careful on this one. Make sure that you're flipping your ratios. So let's start with the first one. Don't forget to type in the negatives. The negatives on this one will make a difference. -2 over -1, 0 over 0. Anytime you guys have a 0 over 0 on a table, it's kind of like a free point. It doesn't necessarily count. Okay. Oops, see, I just did it. It's 2 over 1. Make sure you're being careful. Here, I have a 2, 2, 2, and 0, 0. Remember, I want to know if these tables are proportional, right? And in order for a graph to be proportional, it has to go through the point 0, 0. So that's kind of an indicator that this could be a graph that is proportional. However, since all of these other answers reduce to 2, that means yes, this first graph here is proportional. So yes, this first graph is proportional. Let's look at this one underneath it. I'm going to just type these ones in. So I have 21 over 3. I have 35 over 5, 49 over 7, and 63 over 9. All of these reduce to 7, which means that this is proportional. Let's double check this one over here just to make sure. 0, 0, I don't need to type in. I have 12 over 2, 20 over 5, and 28 over 6. So you can see here that these numbers are not the same. Since they are not the same, that means this table is not proportional, and neither is that one. Our next question says, what is the unit rate for the situation represented by the table? Okay, well, it looks like I'm given hours worked. It looks like in wages, which is how much money I'm earning. Remember, guys, that when you have money, money always goes on top when you're writing your ratio. Okay, so I can pick any one of these and it's going to give me the same answer. I'm going to pick this one here just because the numbers are the smallest. So 35.25 over 3. I want to know how much I make for every 1 hour. So I'm going to divide top and bottom by 3. So that's going to, whoops, I don't know why I moved that over there. Let's do 35.25, divide that by 3, and I get 11.75. Which means that I would make 11.75 every hour. Next question says, which equation represents a proportional relationship? On this one here, we're typing in both sides of our equal sign to see if they reduce to the same number. If they do, that is what is proportional. Some of these may have an X next to them at the top. Ignore the X, pretend like it's not there. Okay, the X doesn't change how we're typing this into our calculator. So I have 4 over 20. And then I have a 1 over 20. These are not the same numbers. This one is not proportional. Let's check our next one. I have 4 over 6. 6 over 44. These two here are not proportional, right? Both of these decimals are very different. Let's check our third one. 2 over 14, 3 over 21. Ooh, both of these decimals here look identical, which means that these two fractions equal the same thing, which means that this is a proportional relationship because I have the same number on both sides of my equal sign. For the top two, they did not equal each other, and for this bottom one, they will also not equal each other. Our next question says, the distance in meters d that Josephina walks over time in minutes t is given by this equation. D equals 125 t. How many meters does Josephina walk per minute? Guys, this question is asking you to find the unit rate given this equation, and remember that your unit rate is whatever number is attached to your variable. Here, that 125 is attached to my variable, so my answer here is 125. And that is it. That is all that you're doing for this question. Please do not get this one wrong. Next one, so this next question here, there is a lot of information that they are throwing at you with all of these numbers and all these different months, okay? Essentially what this problem is asking you is it's saying that LeVar claims that the number of movies is proportional to the amount of data that's used. So essentially he's saying the more movies you watch, the more data you use, and we want to help him prove that his method is proportional. Okay? Think back to all the different ways that we know data can be proportional, right? We could create a graph that, as long as it's straight and it passes through the origin, we could have a table and make sure that each rate reduces to the same amount. Okay, so that's what we're thinking of here. You're not doing anything with these numbers that they give you up here. This is just kind of, it makes it look more overwhelming than it is. So based off what we just said, I know that if he plots data points and he creates a graph with a straight line and it passes through the origin, that is one way of knowing that this data is proportional. Okay. It says that LeVar could create equations based off of the data collected to prove as the number of movies he streams increased, the amount of data also increased. Okay, let's read through all of the rest of these first. He could create a table listing the number of movies he streamed each month and the amount of data he used for those months to prove that the ratios are equivalent. Okay, so this part here with that equivalent ratios, that part is huge because that is what we look for when we have a table, right? And this bottom one here talking about he could divide the amount in December, that doesn't make sense because he'd have to do that for every month and it's not saying that. So the two that we want to look for here is the first one where you're creating a graph that has a straight line and passes through the origin, and then the second one is creating a table where we're making sure all of those ratios are equivalent. All right, we're almost there, we're almost done. Our next question says that Greg's soccer team is selling sets of 3 raffle tickets for $7. What is the constant of proportionality? So this word here that they just kind of throw at you, this constant of proportionality, is another way of saying unit rate. Okay, so don't freak out with this question. It's just asking you what is the unit rate. So how much am I spending for each ticket? Again, I'm given money, so I'm going to put money on top, and that is for 3 tickets. I want to know how much I'm paying for 1 ticket. So I'm going to divide my top and bottom by 3, and I'm going to bring out my calculator, and I'm going to do 7 divided by 3, and it tells me that I pay $2.33 for each ticket. Okay, so don't let that constant of proportionality throw you off. That is just another way of asking for the unit rate. And last question, the school store sells 4 pencils for 62 cents. What is the constant of proportionality? Again, this is another way of asking for the unit rate. 62 cents, this is money, right? 62 cents is money, so I'm going to put that 62 cents on top. And that is going to buy me 4 pencils I want to know how much it's going to cost for one pencil. So to do that, I need to divide by 4 on the bottom, and I'm also going to divide by 4 on the top. Then I'm going to bring back my calculator. I'm going to do my 62 cents and divide that by 4. On this question, guys, please don't forget your decimal here in front of your 62. Okay? And this tells me it is 1.55. However, this doesn't make sense, right? Because with money, we don't have 3 decimal places. So because this is a 5, I'm going to round up that 5 to a 6. So I'm going to say I'm paying around 16 cents per pencil. Whoops. Alright guys, that is all that I have for Unit 3. If you have questions or would like another retake on this exam, please let me know. Other than that, thank you for watching.